sorry I couldn't be in class today. I have a meeting that I had to attend. But I thought that it would be a good idea to take a day and kind of review everything that we learned in this unit before spring break, just in case you forgot stuff while we were out of school. So here are the 4 things that we've learned in this unit so far. The first thing is how to identify what a polynomial is and what it isn't, including classifying them using the terms like constant monomial or quadratic trinomial, those type of things. The next thing we did was identify the graphical features of a polynomial, like whether or not the ends go in the same or opposite directions, whether it goes up to the right, the maximum number of terms that a polynomial could have. And then the next thing we did was how to factor a polynomial just by taking out a greatest common factor and seeing if the factor that remains can be factored further using what we learned with just factoring quadratics. And then we use factoring and the quadratic formula to solve polynomial equations. So just to be clear, for number 3, when you're trying to factor a polynomial, you're just trying to break the polynomial up into the pieces that multiply to make the whole thing. And what you're trying to, for number 4, when you're trying to solve a quadratic, your answer should be something like x equals 5, 7, and negative 2. You should get something where you have answers that x equals something. So let's try to take some time and do practice ones of the first type. So let's identify what a polynomial is and what it isn't. So a polynomial is one or more monomials added together. So the powers must be whole numbers. You can't have a power that's a negative number, and you can't have a fractional power. So let's just go through and decide if any of these 4 are polynomials. If they are, we're just going to classify them. So if we look at the first one here, this is a polynomial because it's just 3 monomials added together. So because the degree is 3, the degree is just the highest power. Our degree is 3, that means that this is a cubic. And there are 3 terms, so that's a trinomial. So now let's look at this one over here. So this one is not a polynomial. The reason that it's not a polynomial is because this x is in the denominator, which really means that it has a negative power. We're going to discuss that more later in the year, but this is not a polynomial. The power is not a whole number. Remember that a whole number is both positive and it doesn't have any decimals or fractions. Okay, so now this one here is also not a polynomial because of the square root. So the square root really means x to the 1/2. So that 1/2 is not a whole number, so it's not a polynomial. Now this one here is a polynomial because its powers are just whole numbers and there's just 2 terms added together. So because the power is 5, that's a quintic. And there's 2 terms, so it's a binomial. Hopefully this is refreshing you a little bit. So now let's move on to the second thing that we've done in this unit. So far we've tried to identify the graphical features of a polynomial. We're not trying to be very specific in the graph, we're just kind of trying to give a general sketch. So the end behavior is the first thing. So the way you should look at first is if the leading coefficient, so let's make sure that we know what the term leading coefficient means. The leading coefficient is just the number that's in front of the term with the highest power. So if the leading coefficient is positive, then the right end goes up. If the leading coefficient is negative, then the right end goes down. If the degree is even, then the ends go in the same direction, like this. And if the degree is odd, then the ends go in opposite directions, like that. And also let's talk about the maximum number of terms. So it's 1 less than the degree. So if your degree is 5, then you could have a maximum number of 4 terms. In your graph could look like your graph could look like this. The degree is 4, so 1, 2, 3, 4. The degree is 5. Our maximum number of turns could be 4. Turn here, 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 and here. But it doesn't have to be. If our degree is 5, we know that the ends go in opposite directions. It doesn't have to have any turns. This is just a maximum number of possible turns. It depends on how many times your graph hits the x-axis. So let's identify the degree and the leading coefficient of each of these, and let's use them to determine the end behavior and the maximum number of turns. So when you're going through these problems, I think it's probably a good idea to label your degree and your leading coefficient. So here our degree is just the highest power of our polynomial, so our degree is 4. And our leading coefficient is just the number that's in front of the term that has the highest power. So because that term has the highest power, there's no number in front, our leading coefficient is 1. It's positive. Now that we know that, let's determine the end behavior. So as the graph goes to the right, it goes up because the leading coefficient is positive. So it goes up to the right. Now, after you determine what it does to the right, let's think about what it does to the left. Because the degree is 4, the ends go in the same direction, meaning that if it goes up to the right, it goes up to the left. And now let's talk about the maximum number of terms. So because the degree is 4, there could be 3 terms. So let's just give you a general idea of what this sketch could look like. Both ends go to the right. Maximum number of turns is 1, 2, 3. Or the graph could look something like this. But both ends go up. And it has maximum number of 3 turns. Okay, let's try the next one. Oh, let's do our joke of the day first. To break this up, I know you guys are getting bored. Stop talking to each other. Please get off your cell phones. Do what you're supposed to be doing. Take notes. Okay. Can bees fly in the rain? And the answer is no, without their little yellow jackets. Okay. Next one. So here we have y equals negative 5x cubed minus 100x. So the degree here is, everybody say it. I wonder if you cooperate or not. The degree is 3, and our leading coefficient is negative 5. So because the leading coefficient is negative, this graph goes down to the right. Now the degree is 3. Because the degree is odd, that means that the ends go in opposite directions. So if it goes down to the right, it goes up to the left. And now the degree is 3, so the maximum number of turns is 2. So it could have 2 turns. So now let's just give you a general idea about the graph. So we know that it goes down to the right. So this part goes down. It goes up to the left. That part goes up. And it could have 2 turns. So it could look like that. Or it could have no turns. So it'll kind of just flatten out. Look like that also. Alright, now let's move on to the third thing that we did. So here we have factored polynomials by taking out the greatest common factor and seeing what was left and looking at what was left and determining whether or not it could be factored anymore. So here, first thing we want to do is always look for a GCF, which stands for greatest common factor. So in this first polynomial, our GCF, first look at the number. Are there any numbers that could go into all 3 of the coefficients? Yeah, 4 could go in. What about any variables? X could go into all of those, so we're going to take an x out. If I take a 4x out of the first term, I'm left with just x squared. Remember, when you're factoring, you're really dividing. 4x cubed divided by 4x is x squared. Now, if I take a 4x out of this term, I'm left with 3x. And if I take a 4x out of that term, I'm left with nothing. But when you're dividing, you're left with 1. So now you have to look to see if this part's already broken up as much as it can be. But there's potential for this part to be able to be factored more. So you should ask yourself the question, can each numbers multiply to 1 and add to negative 3? Because no numbers can do that, it's factored as much as it can. So we've broken this up as much as it can be broken up. Now let's move on to the next one. The first thing you should always do is look for a greatest common factor. So if I try to see what's in common here, it's an x. If I take an x out, I'm left with x squared minus x minus 6. Now, this first piece is broken up as much as it can be. You should look over here and see if that piece can be broken up anymore. So, are there two numbers that multiply to negative 6 and add to negative 1? And yeah, the two numbers are negative 3 and 2. Because there's no number in front of this x squared, I don't have to worry about the whole factor by grouping thing. I can just do the shortcut. So the two numbers that do that are negative 3 and 2. So I can just jump to that answer. Don't forget to bring this x down. It's there all along. Now, what would happen if I multiplied this out? Hopefully you realize that if you multiply this out, you're just going to get the same thing back again. These two expressions, this one and this one, are equivalent. They're the same thing, they're just written in different forms. Kind of like 60 is really the same thing as 2 times 2 times 2 times... That's right. Let's try it again. So 60 breaks up into 4, 15. 15 breaks up into 3, and 5. That was the problem. So 60 is really the same thing as 2 times 2 times 3 times 5. 60 and 2 times 2 times 3 times 5 are equivalent, just like this expression and this expression are equivalent. Meaning the same thing, just written in a different form. Okay, one more. So now let's look at this example and see what the GCF is. No number can go into 8, 10, and 3, so it's just a variable that can come out, just an x. If you do that, you're left with 8x squared plus 10x minus 3. Now, this one does have a leading coefficient in the term that's left over, so you need to see if two numbers multiply to negative 24, those two together, and add to 10. So, negative 24 can be 12 times negative 2, so they add up to 10. Now, at this point, hopefully you remember the whole factor by grouping thing, because we've done it about 400 times. So if it's not second nature to you, you need to do more practice so that it comes naturally. So here, this 8x squared plus 12x minus 2x minus 3. So this and this are equivalent. Then you look for what's in common here, and it's 4x and 2x plus 3. Then you can take out a negative 2 for these two. Sorry, negative 1. 2x plus 3. So now my two expressions are 2x plus 3 and 4x minus 1. And don't forget to bring that x down. So here we factored it completely. We've broken it up into all the parts that make it. So remember that when the directions say factor, you're not trying to get an answer like x equals something. You're just trying to break it up into its parts. And here we've done that. We've broken up this polynomial into what multiplies to make it. Now let's move on to the ones where you have to solve the equation by factoring first, and then if you can't factor, you should try to use the quadratic formula. So here, I know that you're done with examples, but we're almost done. I promise this is my last slide, I think. Let me see. Yeah, last slide. I'm not tricking you. Okay, so 3 more examples. I know it's a lot, but there has to be 3 because they're all kind of different. So let's try this first one. First thing you should always do is look for a GCF. So our GCF here is just easy. It's just x. So let's take that x out. Then we're left with x squared plus 4x plus 3 equals 0. Now this is an equation. You're trying to figure out what makes that equation true, what value of x works. So the first thing we want to do is factor as much as we possibly can. So we've done the first step of taking out the x. Now we should see whether or not this breaks up anymore. So, what two numbers multiply to 3 and add to 4? It's just 3 and 1. Now we're going to use the zero product property. Remember that if you have a few things multiplied together to equal 0, one of them's got to be 0 in order for it to be true. So we have 3 options for what could equal 0. Either x could equal 0, this could equal 0, this part could equal 0. That's my sideways equal sign, if you realize. So here, our answers are x equals 0. This part, there's nothing to solve for x. It's already alone. Here, if I want to get the x alone, I have to subtract 3 from both sides. Which is going to leave me with x equals negative 3. And here, I would subtract the 1 from both sides, which leaves me with x equals negative 1. So let's see if our solutions work. Let's just take negative 1 and let's plug it back into the original. Just to convince you that I'm right. I think you believe that I'm right now. We'll see. Maybe you're still skeptical. Alright, so negative 1 cubed plus 4, negative 1 squared plus 3 times negative 1 equals 0. Alright, negative 1 cubed is negative 1. Negative 1 squared is 1 times 4 is 4. Then negative 1 times 3 is minus 3. And that does equal 0. So that, when I plugged that solution in, it gave me something that was true. That would be true for any of these three solutions that I plugged in. So in a multiple choice sense, if you weren't sure what the answers were and you forgot how to factor, you could always plug them in and see which ones gave you a situation that was true. But that's kind of cheating. Anyway, so let's do this next example. So the first thing you should look for is a GCF. Anything can come out of all of these. No number is going to 3, 8, and 4, so just an x comes out. So I'm left with 3x squared plus 8x plus 4 equals 0. Now you should once again try to see if this can be factored further. Do any numbers multiply to 12 and add to 8. So those numbers that work are 6 and 2. So you should try to rewrite this to be 3x squared plus 6x plus 2x plus 4. Now, what can come in out of those two? What's in common is 3x. What's left is x plus 2. What can come out of these two is 2. X plus 2. So our factors are 3x plus 2 and x plus 2. Don't forget this x. So now we're going to go through and set each piece equal to 0, just like we did over there. I won't do it sideways this time. So we're going to set x equal to 0. We're going to set 3x plus 2 equal to 0, and x plus 2 equal to 0. So x equals 0 is already done. There's nothing to solve for. Now let's do this one. I'm going to subtract 2 from both sides and divide by 3. I get negative 2/3. If you need to write that out, then write it out. Here I'm going to subtract 2 from both sides and get negative 2. So what would happen if I took negative 2/3? And that would be a pain because it's a fraction. You guys just, totally decompose when there's a fraction. But if I took a fraction, I plugged it into the original, what would you expect to happen? Hopefully you are saying or thinking that the answer on the left side will be 0. Alright, one more example, and then I promise you won't have to hear me talk anymore for at least till tomorrow. So now, once again, look for GCF. Take out an x. I'm left with x squared minus 8x plus 6. Now, you should ask yourself, can this factor further? Are there any numbers that multiply to 6 and add to negative 8? You think about it for a little while. There's no numbers that make that work. Because this cannot be factored further, how do you solve a quadratic equation that you can't factor? And you have to use the quadratic formula. So, that's kind of the point. But no other way. So, well, you could do complete square, but I don't think you guys hate that more than quadratic formula. So now we're going to do negative b plus or minus the square root of b squared, which is 64, minus 4 times a, which is 1, times c, which is 6, all over 2 times a. Now, let's try to simplify this a little bit. I have 64 minus 24. 64 minus 24 is just 40. So I have 8 plus or minus the square root of 40 over 2. Now you should try to simplify this as much as you can. The square root of 40 can be broken up into 4 and 10. So because 4 is a perfect square, you can take it out of the radical. And you get 8 plus or minus 2, because that's the square root of 4, root 10 over 2. And now you should see if anything goes into all 3 pieces. A 2 can go into each piece, so you really have 4 plus or minus root 10, because 2 divided by 2 is just 1, all over 1, because 2 divided by 2 is 1. So that's your one answer, and hopefully you realize that there's another answer here. That other answer comes from this x that we kind of ignored while we were doing this. Don't forget it. Don't forget, you said that piece equal to 0 too. So 0 also makes this equation true. So there's your lesson. Now you guys have a little worksheet to complete with your partner on all of these topics. Thank you.